Hey, it's Mr. Lum again, and today we're going to be talking about the relative strengths of acids and bases. So we're going to be talking about how do we determine if an acid and a base are reacting, if it's going to be favoring the products or the reactants. But first let's take a look at this question we have right here. So the question says, write the reaction for HS- and H3PO4. Okay, we see on our Bronsted-Lowry acid-base chart that we can find phosphoric acid, which is H3PO4, and we can also find HS- right way down here. It's a little bit further down on the table. But what we're going to do is we're going to write these things up. Okay, so we're going to write H3PO4. Okay, and that's going to be added to HS-. Now, we can also see from here that H3PO4 is going to be acting as the acid because left side is acids and the right side right here, these are bases. Okay, now HS- is amphiprotic, but H3PO4 is a much stronger acid than HS-. We're also going to, since H3PO4 is an acid and is going to be acting as an acid in this reaction, and the definition of an acid is something that loses a proton, and HS- is going to be acting as a base, or in other words, it's going to be something that gains a proton. HS- is going to become gaining a proton, and it's going to be turned into H2S. And H3PO4 is going to be losing a proton and therefore turning into H2PO4-. Okay? Now the next question right here, it says, will the reaction favor the products or will it favor the reactants? So let's take a look at, and remember way back from chapter 2, how to figure out if something favors products or something favors the reactants. And what we have to look at KEQ. If KEQ is greater than 1.0, then that means, since it's products divided by reactants, that means the products are in a greater quantity than the reactants. Okay, so if KEQ is greater than 1, that means products are favored. Okay, and if KEQ is less than 1, it means reactants are favored. Okay, so now what we have to do is we have to figure out what is KEQ right here. So I'm going to write a KEQ expression for this reaction, and we're going to see that it looks something like this. So again, KEQ is the products over the reactants. So KEQ is the concentration of H2S multiplied by the concentration of H2PO4- divided by the concentration of HS-, okay, concentration of reactants, and H3PO4. Okay, so we still can't get a number out of this, and we weren't given any numbers, but what we're going to do is we're going to use this table right here and use some of these Ka values. Okay, so what I'm going to do right now is I'm just going to write down what phosphoric Ka equals. So the Ka for this one right here, for this H3PO4, okay, equals the products, which is this concentration of H plus times the concentration of H2PO4 minus divided by the concentration of H3PO4. Okay. Now I'm just also going to write down the exact same thing for this Ka value. So again, I'm going to write another Ka number. Okay, but this time it's going to be for H2S. Okay, and we see here this is also H plus, and this is HS minus, and that's divided by our reactants, which is H2S. Okay. Now, something that we can also notice about our reaction and the two reactions that we have here and here is that they look kind of similar. We have, let's take a look at phosphoric acid right here. We have H3PO4 and it turns into H2PO4. And this one is also H3PO4 and turns into H2PO4. Okay? Now, this one is a little bit different. This one is HS minus, okay, and it's turning into H2S. So in other words, it's the exact opposite. H2S is acting as an acid, but it starts on the product side, and it's going this way. Okay, so if we want to make this Ka value relate to our original reaction right here, what we're going to do is we're going to inverse it, because this is products over reactants, okay, but clearly we have H2S is on the top here, so I'm going to inverse it. So I'm going to go 1 over Ka, okay, and it's going to be the Ka of H2S, okay, and since I flipped this one, I'm going to also flip this one. So this is going to be H2S over H plus and HS minus. Okay, so now this one right here, this Ka value, looks exactly the same as this one, except it's just going, we just took this number and we put it over here, and this species, and we put it over here. Okay, and so that means since we flipped it, we also have to put this and inverse this. So this is over 1 over 9.1 times 10 to the minus 8. Okay, now let's go back to our KEQ expression. Okay, because our KEQ expression is just our two Ka expressions we're going to learn. Anyways, let's take a look. So we have KEQ equals, okay, and what I'm going to write here is I'm going to write the inverse of this one. I'm going to write H2S, okay, and it's going to be divided by H plus HS minus. Okay. Now, so what I'm going to do is I'm kind of splitting this reaction just right up the middle right here, and then I'm just going to be multiplying it by this one right here. This one right here, the H3PO4 one. So we didn't have to flip this one, so it's going to be just H plus and H2PO4 minus and divided by H3PO4. And we see it's the exact, these things are exactly the same thing, because as we know, H plus can just cancel out with this H plus right here, and we see that these are perfectly related. So this right here is also just 1 over KAS. So I'm going to again rewrite this formula, and what I'm going to do is I'm going to take this and I'm going to replace it and put it into here, and I'm going to take this because it is also equal to this, and I'm going to put it into here. And so actually our KEQ equals our 1 over Ka of our H2S times by our Ka of our H3PO4. Okay, and that is a formula that we have just derived and that you can use on a test. Okay, so this formula, well, let's solve this problem before we talk about the formula. So if we start replacing some of these numbers, our KEQ, and I know we're running out of room right here, but our KEQ equals our Ka, which is, as we see here, 7.5 times 10 to the minus 3. Divided by our Ka of our H2S, 9.1 times 10 to the minus 8. Okay. Now we see this is a much smaller number, so our KEQ is going to be much greater than 1, and I've already done this calculation, and our KEQ, if I, okay, again this is 2 sig figs, our KEQ, and I'll just keep it the same as 2 sig figs, is 82,000. Now that's clearly greater than 1. And so what we can say is, which one is favored? Well, our products are favored, okay, for this particular reaction, and that's how we do it. Now, on a test, on a test question, you don't have to do this long deriving the things, but what we can do is we can just use this basic thing that we have come up with in order to answer all these kinds of questions like this. What we have right here is we have the Ka of the reactant acid and the Ka of the product acid, and that's what our KEQ equals. Okay, so I'm just going to clear this so we can get a new slate, and so what we can say is, after that whole long deriving that whole formula, all you have to really memorize is this is KEQ equals our Ka of the reactant acid divided by the Ka of our product acid. Okay, and the other things you have to memorize are KEQ. If KEQ is greater than 1, then favors products. And if KEQ is less than 1, well, it favors the reactants. Okay, so I know normally we're used to seeing KEQ as products over reactants, but as you can see in the previous calculation and deriving a formula right there, we can see that YKA of the reactant acid is divided by the Ka of the product acid. So it seems a little bit backwards, but you're going to have to trust me, it is correct, and go back and take a look at that one. Okay, so that's how we tell if the reaction is going to favor products or if it's going to favor reactants when you have an acid and base reaction. Okay.